Have you ever pondered the fascinating revolution of three-dimensional printing in the field of engineering? It's an intriguing journey, isn't it? Let's embark on this trip through time and technology, exploring how 3D printing has radically transformed engineering. It all began in the early 1980s. Yes, that's right, the 1980s. A time when the world was just getting acquainted with the magic of personal computers. In this era, an ingenious inventor named Chuck Hull was working tirelessly on a concept that would later be known as stereolithography, the very first form of 3D printing. This was the seed that would grow into the expansive forest of 3D printing we see today. Fast forward to the 21st century, and 3D printing has evolved from a novel concept to a practical tool, widely used across various fields. In engineering, it has become a game changer, offering unparalleled advantages over traditional manufacturing methods. One of the most significant benefits of 3D printing in engineering is the ability to create complex geometries and designs that would be challenging, if not impossible, to achieve with conventional methods. This has opened up a world of possibilities, enabling engineers to push the boundaries of design and innovation. Moreover, 3D printing has dramatically accelerated the prototyping process. Engineers can now bring their ideas to life in a matter of hours, not weeks or months. This rapid prototyping has significantly hastened the product development cycle, allowing for faster innovation and iteration. Beyond prototyping, 3D printing has started to make its mark in the production of end-use parts. From aerospace to automotive, medical to manufacturing, 3D printed parts are increasingly becoming a reality. This shift is thanks to advancements in materials science, with high-performance polymers and metals now available for 3D printing. In essence, 3D printing has transformed the field of engineering by enabling the creation of complex designs, accelerating the prototyping process, and paving the way for the production of end-use parts. But the journey doesn't end here. With continuous advancements in technology, who knows what the future of 3D printing in engineering holds? So, what did we learn today? We started with the inception of 3D printing in the early 1980s with stereolithography. We then explored how it has evolved over the decades to become a vital tool in engineering, enabling the creation of complex designs, fast prototyping, and the production of end-use parts. As we look ahead, it's clear that 3D printing will continue to play a pivotal role in the field of engineering. It's not just a tool, it's a catalyst for innovation, a driving force for change, and a symbol of the limitless potential of human ingenuity. The future of engineering is here, and it's three-dimensional.